Hey, everybody. All right. 10 years from now, I'll see that and go, oh, man, I remember those guys. Oh, that's going to be so creepy. You're young, Jeff. Now you're old. Oh. And you guys are like, you're not young, Jeff. All right, shut up. So, 3x, what is it? 3x
Squared.
fifth? You know what this is. 3 times
X.
4
4.
is
12.
how many x's total you got?
7.
Done. Why was that easy? Because everything is being multiplied. It's when I have a combination of operations. So what we're going to learn later today is what to do with something like this. Again, square. Right? These are based on multiplication. There's a minus sign inside. This has to be more complicated. They're not going to act well together. So later today, but if the parts involve multiplication, then it should be easy. So even that problem from earlier, what if I had, x minus 2 squared times x minus 2 to the 8th? I don't really want the 2 each piece, but how can I do something?
Yeah.
Why? Because what's this operation? Multiplication. What are these based on?
Multiplication.
That's why they're so easy. I don't know why. I'm talking. Ask not what you could do for me. All right. So how many x minus 2's do I end up with?
X minus
10.
Yeah.
X minus 2. I got 2 of them here times another 8. Means I got a total of 10. You guys all right? You guys?
The
What's up?
first one, because it's 3, so because 3 would be 3 times x basically. That's the reason we do 12x.
Well, it's 3 times. I can't do shit with these,
Yeah.
but I can do 3 times 4. Now, for example, if you had to do 2 times 11 times 5, I would do 2 times 5 first, because that's 10, and anything times 10 is easy, right?
Yeah.
So over here, can I even do this times this?
No.
No, so I'm going to do this times this, not just because it's easier, but because it's possible, right? So if everything's multiplication, you can multiply whatever order you want to, because you're in the same level in PEMDAS then. Nothing has to come before anybody else.
Oh, okay,
So if everything's numbers, you do it the way that makes it easiest. If it's a mixture of numbers and letters, you do it the way that's possible. So here, the one we did earlier that, let's see, let me make it a slightly different one. You can do it, Jeff. W squared z cubed times w to the 11 z 4. Can I do w times z? Nope, but I can do w squared times w 11. What would that be?
13.
13 w's, and how many z's?
7.
7. Because everything is multiplying, so I can do the multiplication any order I want to. 2 times 4 is the same as 4 times 2. That's commutative property. Oh shit.
I have a question. So
Yes.
if it was 3 to the second power times 5 to the second power.
Okay, that's just like the one we did earlier.
Yeah.
Now that you could do something with, it's a little bit weird, but isn't this 3 times 5 squared? And then 3 times 5 is 15. So that's sort of like that earlier one we were creating 15s if we had enough 3's and enough 5's.
Oh.
With 2 3's and 2 5's, I can make 2 15s. But that middle step is really kind of why. Can't reach you guys. Yes?
So like something like this is s to the third power and then there's just an s. Would it still be s to the third power or s to the fourth?
Now, if you said the answer was s to the third, then you're telling me that s is the same thing as 1. But what is the exponent known to be? So it does provide me with one more s, right? So now I've got s to the fourth.
Yesterday you said it has a 1 has a 1.
Yeah. So when I write x, or any letter, it's got a 1 here, it's got a 1 there, it's got a 1 underneath there, and there's even more ones that we're not going to. There's a whole lot of just known things. that only show up in certain situations. Like why? What is x divided by x? Where the shit that come from? Because it's there. So when these cancel, it's there. So it doesn't show up unless it needs to. Sort of like that. So the x to the 0, what's that?
1.
Where the shit that come from? Well, it's right there. I got a 1 times no x's. All right, that's 1. If I said take 7, now multiply that by no 2's. It's 7. What the shit? You guys see what I'm saying? So that's 0 exponent. The most direct way to see that is there are no x's. All right then, I'm not going to write them because they aren't there. So we talked yesterday about why anything to the 0 power is 1. Except 0. All right. So, anything else from there you guys see that looks interesting?
This number 1 on the bottom.
Oh,
Or is that this? Did you show
yeah,
us that
we
already?
did. Yeah. What would this be?
Is it would be 5 of the x squared?
Yeah, x to the 10th.
Oh,
Because there's 5 groups of 2 x's.
right. Okay.
And that's like when you first learn multiplication, 5 crates, and they each got 2 apples. And how many apples are there?
So when it's so when a power is inside of parentheses, you got power outside of it, you times it by.
Totally.
Oh.
I love it.
But if there's a 0 on the outside of it.
Yeah, I mean, what's
Two
this?
One.
When I'm feeling really evil, I kind of make a problem like that. With other shit happening inside, with some other z's and some other y's and some numbers and shit. So it's 1. Anything to the 0 power is 1. Why? Because what's x squared divided by x squared? Well, 2 minus 2 is 0. Well, what's something divided by itself? Okay.
But you said except 0.
Yeah, except 0. That's not going to come up for us.
So that's
So what is it? 5?
Yes. Okay. All right, this is the last one we'll do off here. We got to do some new stuff.
bless you. Bless you.
I want you to realize I just wrote 3 problems up there. There's a problem with numbers, there's a problem with x's. Actually, I wrote 4 problems. Problem with numbers, problem with x's, problem with y's, problem with z's. Each one of them is easy. 3 over 12, what's that? 1/4. Beautiful, not 4, right? How many x's are left? 1. On top. I love it. How many y's are left? 4. Up top. How many z's are left? 1. Up top. Become a z. So if you just attack each piece one at a time, the overall problem isn't hard, it's just got a lot of little easy problems in it, is my hope. So if I had something like this, well, it's not 6, I don't know, stone. What you got, Jeff? Yeah, 1/5. I like it. I don't put the 1, of course, right, because it's wouldn't show up with the rest of the stuff. How many y's left? 3 on the bottom. You guys see that?
Yeah.
2 kill each other. 3 are left down here. And then how many z's where? 3 z's on the top. If it was 2 z's on the top, I really got it. Ah,
So it's kind of like.
but I didn't think that far ahead.
So it's kind of like, well, the first part isn't really kind of like eliminating, but the later part is eliminating.
No, this is still, I want you to realize, what's funny here is, why did this work? Because, so what's 4? It's 2 squared, right? And what's 20? It's 2 squared times 5. 2 minus 2 is 0. 2 to the 0 is 1. That's why there's a 1 up here. So letters and numbers don't actually operate differently. It's just that the numbers and letters are not written in the same form. So for example, if I saw 64 over 16, I can write that as 4 cubed over 4 squared. And what would that be? 3 minus 2? So you get 4 to the first, which is what 64 divided by 16 is. So the only reason that numbers seem to act different than letters do is because they're not written in the same format. What I get is I'll get problems like this, and I'll have somebody tell me, you could do it, Jeff. There you go, buddy. I'll have somebody say this to me. The answer is 2y to the 5th. Is that right? What did they do? How did I get a 5 there? 7 minus 2. So what'd they do? 8 minus 6. Holy shit. That's never happened like that, right? So I can't teach you something that changes anything we've ever done before. That's impossible. So if you actually think we're learning something that changes what we did before, you got to come see me, because you're not looking at it right. Okay. So let's get into something new. I can't remember if I said this, but that exponent stuff is from section 6.2. So we're sort of skip 6.1 for the moment, because exponents are the main thing about polynomials. That's what kind of makes the terms different. So I wanted to start with those. So we're kind of taking a step back into 6.1. So what is a polynomial? But
Combination of
that's what that's what that word means.
binomial.
But what makes it mathematically a polynomial is something that is defined for all values of the variable. Holy shit, Jeff. Why you gotta make everything hard, Jeff? What's wrong with you? So, for example, is this a polynomial?
Yes.
Is it defined for every value of x? Can you guys think of a value for x that makes that undefined? 0. So polynomial cannot have any variables underneath, because then when you plug a 0 in for them, that piece is undefined. So when a math person tells another math person, like we often do, hey man, I got a polynomial. Oh really? Then we both understand that I can use any input I want to, and it won't freak it out. Right? Nowhere is it going to become undefined. So later, when we start graphing these bad boys, this is where you get the graphs that look like this. You know, they just keep going, or even like this, up forever and down forever, right? Yes. So you get a graph that looks like this. Woo-ha! That's some kind of cubic. How do I know that? How many turning points does it have? 2. So it always has at most one less turning point than the degree it is, the power that it is. So that's a cubic. That's in our future. Okay. So polynomial has to be something where it's a collection of variables and powers where the powers are whole numbers. The powers have to be whole numbers. Negative powers would actually make it flip. And we're going to talk about that, apparently, when we get to rational expressions. That's in our future. So this is a polynomial, more specifically, so this is a polynomial, check. What kind of polynomial? Well, how many terms does it have?
2.
2. So this is what's called a binomial. I like it. So, not surprisingly, well, let's see. What kind of polynomial is this? Monomial. What's it mean when somebody's got one lens? They put it in. Monical. So it's monomial. It's not uninomial, like a unicycle. Too bad. They didn't pick that. They picked monomial. So what would it be if it had 3 terms? Holy shit. So that's your classic. That's a try. It's trying to be a nomial. Trinomial. And the one that hides around the corner is just shining and all that kind of stuff. I'm seeing it. Sorry. Now past this, we just go screw it. We're going to call everything else polynomial. We got many terms. We don't go quintinomial and sextinomial. Holy shit. Right? Okay. Now, let's talk about something. The degree. I said this word before, but what would the degree be? The degree of a term.
It's the highest power or the highest exponent.
Yes, but it's more than that, so we got to be a little careful. So I'll start with this guy. Let's do this. So the degree of this term is a 7th degree. That's amazing. But what's the degree of this term?
3.
No. So the degree is the total number of letters I see in a term. I see 2 A's and 3 B's, so I see a total of 5 letters. So it's 5th degree. So to be honest, if 2 math people are talking and I say I have a 5th degree polynomial, that gives the other person an idea of how quickly it grows. As I make A and B bigger, it's going to grow as if it was to the 5th power. It's going to grow relatively fast. You guys all cool with x squared grows slower than x cubed?
Yeah.
Right, 3 squared is 9, 3 cubed is 27, holy shit. Right, so the degree has to capture the overall growth of the thing. So a 5th degree tells me how quickly it's going to grow as my inputs grow. Do we have to actually know that? No, but I want to let you know why the hell we have this idea of degree. So this is a 5th degree. So what's the degree of this one? Let's see. 5a squared b cubed c to the d, Jeff, c, d, e, f, g to the 11th. How many terms is that? No, how many terms?
3.
How many terms are here?
3.
How many terms were here?
2.
2. What are they separated by?
It's the exponent.
What are they separated by?
the
Yes.
addition there.
How many terms are here?
So then it's just 1.
What are they separated by? I could have put a minus, so it's a plus or minus, right? So how many terms is this? 1. A term is connected by multiplication. And then I can add or subtract another term. That is one big ass term. What's the degree of that term?
20.
19? Sure. 5, 6, 7, 8, 9, 20, I think, right? 5, 6, 7, 8, 9, 20. 20th degree. Damn. That bad boy grows. Okay. Again, what's the degree of a term? The number of variables you see. Total number of variables. I see 2 A's, 3 B's, 1 C, blah, 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 20 total. Does that look like the number 20? We try again. All right. Now, what's the degree of a whole polynomial is just the highest degree I see. So if I want the degree of a polynomial, for example, if I had this 6x squared minus 4xy plus 3x. Yeah, what's this guy's degree? 2. What's this guy's degree? 2. I see 1, 2 letters.
Oh, okay.
And what's this guy's degree? 1. So the highest degree I see is 2. So it's a 2nd degree. What kind of polynomial is it? Is that the word degree? Who? Trinomial. I like it. Trinomial. Alright. So you guys look like you're mad at this. I'm sorry.
Oh.
They write them down and like crumple it,
So,
kick it.
You
so,
review
the what is it, 4xy would be the 2nd degree?
2nd degree. No. Alright. This whole thing
Ah, okay.
is a 2nd degree because the highest degree I see is 2nd.
Okay.
So what about this one? What degree is this one? All right, this is going to be fun. Everybody with me? What degree is this one? 4. What degree is this one? 0. What's the degree? The number of letters I see in a term. How many letters do you see in the number 2? You see any letters? It's a number. In fact, I don't know. Isn't this times 1, right? So couldn't I put this there? And it wouldn't change anything, because what's x to the 0? So that's another reason why a constant, just a number, is a 0th degree. Because it has 0 letters. So it would have a 0 power.
1.
You don't need to do that though. Just to let you know, that's really why this is a 0th degree. Yeah, we say this, you ready? 0th degree.
0th degree.
Yeah. I didn't really mean to say it. That's what we say.
0th.
0th. Yeah, it doesn't sound, it sounds like you have some weird list. Oh, how many total letters you see? I see 1 X, 1 Y, and 2 Z's.
Look at the 2, this,
So what's the degree of this whole thing? 4th degree. 4th degree trinomial. So don't let that be evil. It's just the way we develop so we can talk to each other quicker. As all math people, as we all are in this room, we are all math people. If you don't think so, every human is a math person. So if you don't think you're a math person, or you're reptilian, shape-changing thing, I don't know. Every human is a math person.
I found out that every single recent human being can trace back their ancestry to a guy like 300 BC.
What?
Yeah,
Well, where did he come from?
somewhere in.
No. He must have come from somewhere. You should be able to go past him. I thought you were going to say you could trace our ancestry back to this guy named Fred. Who lived down the
I was
road.
just saying all recent humans can trace back their ancestry to one.
Oh, I see. Well, yes, that's true.
One person.
We have to be able to go back.
Yeah,
Yeah.
300.
All right.
That was
It's freaky. So we had to come from one. We didn't. Nobody moved here from Mars and just kept going. I lost my place. Okay. Blah blah blah. Oh, I want to see the other. Oh, I like it. Quick little side note. Let's see what you guys think about this. Can you do that?
Yes.
Yes, you can. How do you do that? Yeah, P of X is this, so P of 1 is, put a 1 there instead. So it'll be 1 cubed minus 7 times 1 plus 1. 1 minus 7, negative 6 plus 1. Negative 5. You guys okay with that? So it's just function. We already talked about functions before. And now we're just saying the functions are polynomial functions. They work the same way as any function. You can just plug that in. What's a point that this function goes through? 1, negative 5. Yeah.
Yeah.
What's P of M? What's P of X? X cubed minus 7x plus 1. That's P of M.
M cubed.
M cubed minus 7m plus 1. Done. See, it's even nicer when that's a letter. You put it in, you're done. Because you don't have any like terms. All right. side note. That's just functions, and they have to be polynomials. So you just plug stuff in, not a huge deal. It's my hope. So,
Jeff, do you think you can explain that one more time?
say again, sorry?
Please explain it one more time.
Sure. So just like we did before with functions, b of x is this. So it tells you whatever I put here, I have to put it here and here. So what's here now? It's not an x, it's a 1. So I put the 1 there, bam, and I put the 1 there, bam.
Where did you get the one?
That was the question.
Oh,
Yeah. So the question would be, this is given, and this is the question. So good question. I mean, there's no way that you could just figure out, well, it should be a 1 there. So I could have asked you, what's p of 2? That's the question. So how do you figure out what p of 2 is? You plug a 2 in, right? 2 cubed minus 7 times 2 plus 1. 2 cubed is
8.
8. 7 times 2. 14. 8 minus 14.
7.
Negative 6 plus 1.
Negative 5.
Isn't that neat?
Yeah.
Should be kind of neat. I didn't do that on purpose, but I like that. Why is that okay? Do you guys, anybody a little bit freaked out that you got the same answer? Because what's this going to do? It's going to curve. It's going to turn. So it's going to have repeated, right? So like I had up here before, that's an output. Well, that happens here too. Oh, and it happens here too. That same output can happen for several inputs because it's allowed to turn on itself. A line can't do that shit. Right? You can't get 2 as an output and 2 as an output somewhere else. That would mean somehow it's curvy and that's not a line anymore. A line is.
And you have another, could another curve go into that?
You could have 2 curves?
Yeah.
Sure, you could. Yeah, but we won't. That's way far in the future. Okay. So is that all right? I mean, that's the same idea with functions we've done before, but now they just have to be specifically polynomials. How do they work? Substitute. That's the basic idea behind function notation is you substitute. You guys doing all right? You guys look. All right. So this has to be easy. Whenever you hear a math person say that, like, shut up. But, so for example, if I have x squared plus 2x minus 1 plus 3x squared minus 4x plus 7. Can anybody tell me the main idea behind what I'm about to do?
You just
Like terms.
combining them.
Like terms. Where are my like terms?
X is
Where are my like terms at?
x squared.
X squared and 3x squared? What else?
2x.
2x.
Minus 4.
Minus 4x. And what else?
Negative 1.
Negative 1, 7. See what I do? Instead of rewriting all the shit and moving things, just use different underlines. Now, real quick. Why do I know for sure that's a negative 4x? Because there's a plus right there. When there's a minus in there, oh shit. So we'll do a problem like that in a minute. There's a plus there, so will it change anything? Did I even need these parentheses? No. So why did I put them there? Because I'm crazy. Plus, I just have this polynomial plus this polynomial. That's the only reason the parentheses are there. I don't really need them mathematically. So what do I get? 4x squared minus 2x plus 6. Bam. So what about this? What about yes?
So you only have the exponents when you multiply the base.
I love it. This is perfect. Exponents are based on multiplication. So it's the only time they can change is if I'm multiplying or dividing. Does that make sense? So, for example, I like that you said that because I'll often get somebody tell me the answer is this, right? I'll get that because they see the 2 and the 2 and they make it 4. And then what I'll say, because I'm a dork, is I'll say, I don't see any x to the 4th anywhere. How'd you get 4 of them? Right? Which I don't know if that's mean or not, but oh well. I'm just trying to make the point, the right way to look at this. That's the way to look at this. There's no x to the 4th. How could your answer have 4 of them then? So what is it, the right way to look at this? I have an x squared and 3 more x squared, so how many x squares do I have? Yeah. So like you said, the only time exponents themselves can change is when I'm operating with something that changes multiplication. That would be multiplying or dividing. And then we have the addition thing and the subtraction thing, those rules. I like it. So this one, what happens here? What do I have to do first on this one? Yes. Because I don't know what I have in here until I distribute this thing. So I got 4a minus b minus 2b plus a. Now I can do some stuff. Right, so I get
Wait, why'd you get plus 8?
4a plus a, 5a, minus 1 minus 2 is minus 3b. Kabam. Kabam. Now be real careful. There's a subtraction here, right? There's no FOIL in this thing. So some of you guys, we've been talking about FOIL before a little bit. If that wasn't there, then it would be times. Then I would FOIL, because FOIL is an answer to multiplying shit with multiple terms. But this is subtraction. So some people, I'll give a problem like this. Can you imagine this problem and somebody starts multiplying this? Oh my God. And I'm like, dude, no. You just had to add stuff.
How'd
So
you
the
get
distribution only happens when there's a times.
I was gonna say, how'd you get plus a at the end if it was minus a?
Negative times positive is negative,
okay.
negative times negative. Yeah. So there's an understood -1 here that needs
Right.
to multiply through.
Okay.
Good. No, yes, maybe, no. Sorry, not staring. You don't have to lie to me either if I'm looking right at you. You can go like, I don't have a clue what the hell you're doing. Okay. Let me think here. I think my plan was to put this on the overhead, not this, but the other. I got another worksheet here, but I figured I would just add heat. So I'm going to give this to you here in a minute. Let me see. Make sure I want to do. Oh yeah, let's do this. We cover the front of this. Let me shut up for a little bit and let you guys try some problems out. Gotta weight down your paper over here. Makes sense.